Hello friends, in this module we will learn about what is clustering and the algorithms that are used in clustering. Clustering is a data mining technique that is used to place the data elements into their related groups. It is the process of partitioning the data or objects into the same class. The data in one class is more similar to each other than those of data in other clusters. This process partitions the data objects into subclasses as a cluster. A cluster consists of a data object with high intersimilarity and low intrasimilarity, and the quality of the cluster depends on the method used for clustering. It is also called as data segmentation because it partitions large data sets into groups according to their similarity. Let us look into a proper definition of clustering. Clustering is the process of grouping abstract objects into classes of similar objects. The cluster is termed as a group of objects that belong to the same class. In other words, similar objects grouped in one cluster and dissimilar objects grouped into another cluster. Let us see the objectives of clustering. The first objective is to minimize the intra-cluster distance, that is, the distance between the objects within a cluster. The second objective is to maximize the inter-cluster distance, that is, the distance between objects in one cluster and another cluster. In this diagram, you can see three circles having different colors of dots. One circle has pink color dots, the other one has red, the other one has blue. What we need to observe here is the distance between the dots in each cluster and the distance between the dots in different clusters. You can very well note that the distance between the dots in a single circle, that is one cluster, is less, and the distance between the dots in various clusters is more. Another observation is that the distance between the clusters is high, that is, the inter-cluster distance is large. Let us look into the types of clustering. First one, the hard clustering. In hard clustering, each data point belongs to a cluster completely or not. For example, diagram which you saw, each customer is put into one group out of the 10 groups. In the diagram you saw, each dot belongs to one cluster and does not belong to two clusters. So, it belongs to either one or not. The next one is soft clustering. In soft clustering, the cluster is formed based on the probability or likelihood of that data point. For example, from the above scenario, each customer is assigned a probability to be in any one of the 10 clusters of the retail store. We need to understand the requirements of clustering in data mining. First requirement is scalability. We need clustering algorithm to be scalable, that is, it should be able to deal with large databases. Another requirement is that the clustering algorithm should have the ability to deal with different kinds of attributes. That is, algorithm should be applied on any kind of data such as interval based numerical data, categorical and binary data. Another requirement is that the discovery of clusters with attribute shape. Clustering algorithm should be capable of detecting clusters of arbitrary shape. They should not be bounded to distance measures that tend to find only the spherical clusters of small sizes. You need to keep in mind that the cluster should be of various types. High dimensionality. Clustering algorithm should deal with low dimensional data and high dimensional data also, because we cannot expect the data to be low dimension, because in many real time applications the data is high dimensional. Another main requirement is the ability to deal with noisy data. Databases may contain noisy, missing or erroneous data, and some algorithms are sensitive, may lead to poor quality clusters if they do not understand the noisy nature of the data. Another requirement is interpretability. Clustering results should be interpretable, comprehensible and usable to the end user. Let me summarize the important points. A cluster of data objects can be treated as one group. First, partition the set of data into groups based on data similarity and then assign the labels to the groups. It should be adaptable to changes and help to single out useful features that distinguish different groups. Let us see what is cluster analysis. So, cluster is a group of data objects where related items, that is similar items, belong to the same group and unrelated or dissimilar items or objects belong to different groups. Cluster analysis. Similarities between data can be found out according to the characteristics found in the data and grouping the similar data objects into clusters. We need to know about unsupervised learning also, where there are no predefined classes. Now, let us look into some applications of clustering. It is used as a standalone tool to get insight into data distribution. It can be used as a pre-processing step for other algorithms. And there are several other applications for this cluster analysis. It is broadly used in applications such as market research, pattern recognition, data analysis and image processing also. Clustering can also help marketers discover distinct groups and can characterize their customer groups based on the purchasing patterns. And naturally, this will increase their profit. Clustering can also help in the field of biology to derive plant and animal taxonomies, categorize genes with similar functionalities and gain insight into structures inherent to the populations. Clustering also helps in earth observation database for the identification of areas of similar land use. It also helps to identify groups of houses in a city according to house type, value and geographic location, and naturally this can be used for town planning. Clustering also helps in classifying the documents for information discovery on the web. Another interesting area is that clustering is used for detecting credit card fraud also. As a data mining function, cluster analysis serves as a tool to distribute the data to observe the characteristics of each cluster. Let us see the general types of cluster. The first one is well separated cluster. A cluster is a set of points so that any point in a cluster is nearest to every other point in the cluster as compared to any other point that is not in the cluster. The next type is the center based clusters. A cluster is a set of objects such that an object in a cluster is nearest or more similar to the center of the cluster than to the center of any other cluster. The center of a cluster is often a centroid. The third type is the contiguous cluster. A cluster is a set of points so that a point in a cluster is nearest or more similar to one or more other points in the cluster as compared to any point that is not in the cluster. The fourth type which we will see now is a density based cluster. Here a cluster is a dense region of points which is separated according to the low density regions from other regions that are of high density. The fifth type is the shared property or conceptual cluster. It finds clusters that share some common property or represent a particular concept. Having looked into the types of clusters, now we will see about k-means and hierarchical clustering. K-means clustering is a simple unsupervised learning algorithm developed by J. McQueen in 1967 and then J. A. Hartigan and M. A. Wong in 1975. In this, the data objects n are classified into k number of clusters in which each observation belongs to the cluster with the nearest mean. The next step is it defines k sets, that is the point may be considered as the center of a 1 or 2 dimensional figure and the k sets 1 for each cluster k less than n. The clusters are placed far away from each other in this step. Then it organizes the data in an appropriate data set and associates to the nearest set. If there is no data pending, the first step is complicated to perform. In this case, an early grouping is done. It is necessary to recalculate k new set as barycenters of the clusters from the previous step. After having these k new sets, the same data set points and the nearest new sets are bound together. Finally, a loop is generated. As a result of this loop, the k sets change their location step by step until no more changes are made. These are all the steps which we have to follow in this algorithm. Let us look into the function which represents this algorithm. This algorithm aims at the minimization of an objective function j, which is represented as the summation of the square of the modulo of the distance between every point and the centroid. We will see in deep about each component in this formula. xi to the power of j represents a data point, Cj represents a cluster center, n represents the number of data points, k the number of clusters, and the square of the modulo of xi to the power of j minus Cj represents the distance between a data point xi to the power of j and cluster center Cj. Now, let us look into the steps in this algorithm from this flow chart. We have to start with finding the number of clusters in the data, that is k. After finding the number of clusters, we need to find the centroid of each cluster. After you find the centroid of each cluster, you have to find the distance of the objects to the centroid in each cluster. After you find the distance of the objects to the centroid, you can group based on the minimum distances. If there is a maximum distance, that point will not come into that cluster. And suppose if there are no data to be grouped, then that means there are no object groups and you can stop the algorithm. Now, let us see another algorithm, that is the k-medoids. Instead of taking the mean value of the object in a cluster as a reference point, a medoid can be used. It is the most centrally located object, also called as partitioning around medoids, shortly called PAM method. In a single partition of data into k clusters, where each cluster consists of a point, this is centrally located in a single partition of data into k cluster, where each cluster consists of a point, this is centrally located point of the cluster based on the distance measure. These representative points are called as medoids. Now, we will see what is hierarchical clustering. Hierarchical structure that is more informative rather than the unstructured set of clusters. A hierarchical structured clustering is more informative rather than the unstructured set of clusters that is written by non-hierarchical clustering. The basic algorithm has only 4 steps. First, you need to compute the proximity or the similarity matrix. Then, let each data point be the cluster. The next step is to merge the two closest clusters. Then, update the proximity matrix until only one cluster remains. There are different approaches to define the cluster between the clusters. The first one is single linkage. Here, the pair of clusters having shortest distance is considered if there exists the similarity between two clusters. The second one is complete linkage. Here, the distance between one cluster and another cluster should be equal to the greatest distance from any member of one cluster to any member of the other cluster. There is another method, that is the average linkage method. Here, the distance between one cluster and another cluster should be equal to the average distance from any member of one cluster to any member of other cluster. We will see a dendrogram. A dendrogram is a picture which is used to represent hierarchical clustering. It is a tree structure diagram that illustrates hierarchical clustering techniques. Each level shows clusters for that level. This diagram has basically 4 levels which represents the data at each level. Now, we will see about agglomerative hierarchical clustering. It is a bottom up approach in which clusters have subclusters. Now, we will see the steps in agglomerative clustering. Now, let us see the steps in agglomerative hierarchical clustering. The first step is that you have to list the objects with their features. Next, you have to compute the distance matrix using the values. After computing the distance matrix, you can set the object as a cluster. If the number of cluster is equal to 1, then we come to the end of the algorithm and we can stop the computation. If the number of clusters is more, then merge two closest clusters. After you merge the closest cluster, you can update the distance matrix and proceed iteratively until you reach where there is only one cluster. So, this is the basic steps followed in agglomerative hierarchical clustering. Now, let us summarize what we have seen in this module. The overall goal of the data mining process is to extract information from a large data set and transform it into an understandable form for further use. Clustering is important in data analysis and data mining applications. It is the task of grouping a set of objects so that objects in the same group are more similar to each other than to those in other groups. Clustering done by the different number of algorithms such as hierarchical method, partitioning and grid algorithms. Hierarchical clustering is the connectivity based clustering. Partitioning is the centroid based clustering. Here the value of k-mean is set. The application of cluster analysis is more and more urgent. The requirements are also getting higher and higher. With the development of modern technology in the near future, cluster areas will achieve a critical breakthrough in many real-time applications. Hope you have had an overall idea about what is clustering, what is cluster analysis, the algorithms which are used in cluster analysis. Thank you.